Bismillahirrahmanirrahim, dear students. Today's topic is about the approach of conductor in electrostatic equilibrium. What is meant by electrostatic equilibrium? Electrostatic equilibrium means that there is no flow of charge and flow of current. Equilibrium is achieved. You know about the equilibrium in mechanics, that a body at rest or moves with uniform velocity, that is static equilibrium or dynamic equilibrium when the net forces are zero. But here in the electricity and magnetism, we know that the electrostatic equilibrium means there is no flow of charge and no flow of current. Then what should be its properties? First property is electric field inside a conductor is zero in electrostatic equilibrium. Means, for example, if you are taking the isolated conductor and the conductor is not attached to external source, that is a battery or etc., then you will find that the field inside the conductor will be zero. Electric field will be zero. Net charge will be zero. Suppose if there was electric field inside the conductor, this would cause free charges inside the conductor to move and hence contradict the fact that they are in electrostatic equilibrium. मुराद क्या हुआ? इससे मुराद ये हुआ कि अगर for example if you say that there is a field inside a conductor and there is no source, no power which has been attached, then here you will find that inside the conductor, if there was an electric field, then under the influence of force, F is equal to QE, F is equal to QE, that charge will be accelerated, electron will be accelerated, and you will have an electric current. But so far there are no such electric current is detected if you are taking the isolated conductor. So it means that inside the conductor to move and hence contradict the fact that they are electrostatic equilibrium. Means if there is a flow of charge, if there is flow of current in the conductor, so it is the contradiction that the conductor is in electrostatic equilibrium. Then what happened when a conductor is placed in electric field? How does internal field come to zero? And if, for example, if there is a field, you have applied it. In the beginning, you see that the electron and positive charge and electron, etc., they are randomly oriented. For example, are uniformly distributed. This is positive charge, and this is negative charge. If external field is applied, what will happen? For example, you are applying external field, then initially when external field is applied to a conductor, the electrons which were uniformly distributed in the conductor will begin to migrate. Under the influence of external field. And produces their own field. Say in figure B, suppose this is external field and this is a positive charge and this is negative charge. Now inside the conductor, the positive and negative charge will develop its own field. And you see that the field which is an external one and the field which is an internal one, both will cancel each other. They cancel the external field. This occurs extremely quickly. Within the period of 10 की ताकत -16 सेकेंड, means in 10 power -16 second, the conductor which where you see there is internal field and there is external field, both will cancel each other, and the migration of the electron will be so quickly that it takes 10 power -16 second. But one thing you must remind, that it depends upon the nature of the conductor, whether it is good conductor, whether it is a conductor, say, or whether it has a conductivity more or less, resistivity more or less. The occurrence of the electrostatic equilibrium is the time which is taken for the electrostatic equilibrium depend upon that. 10 power -16 second means it is a good conductor in this case. इस तरह लेक्चर दो, खैर है। अच्छा, अब वो बाकी आप लोगों को जो वो है वो व्हाट्सएप पे भेजूंगा क्योंकि टाइम कम है। अब अगर इस केस में तो आपने देख लिया कि ये ऑलरेडी डिस्ट्रीब्यूटेड है, फील्ड अप्लाई हुआ, फील्ड अप्लाई होने के बाद रेंडमली ये ओरिएंटेड हुए, ये पॉजिटिव है नेगेटिव है, तो ये भी फील्ड डेवलप करेगा। ये इंटरनल फील्ड और एक्सटर्नल फील्ड जो है इन्होंने आपस में क्या कैंसिल किया। तो कैंसिल करने के बाद नेट फील्ड जो है वो किसके बराबर आ गया, 0 के बराबर आ गया। अब अगर कंडक्टर आपके पास आइसोलेटेड नहीं है, नॉट आइसोलेटेड, means if you have applied a conductor, a power source, that is a battery, etc., then you will see that electrostatic equilibrium will not be achieved, and there will be an internal field. There will be an internal field inside the wire. And the second property is any net charge on isolated conductor reside on its surface. What is the second property? First property was about electric field inside conductor is 0 and electrostatic equilibrium. And the second property is excess charge reside on the outer surface of a conductor. And inside a conductor there will be no charge. This is the second property. Okay. For example, I have taken a sphere shape on which positive charge are uniformly distributed over its surface. If I take the Gaussian surface inside this conductor, then according to Gauss's law, phi E is equal to Q by epsilon naught, or EA electric flux is equal to Q by epsilon naught. is there is no charge at all, so EA is 0 or E is 0. Means excess charge are only residing on the outer surface of a conductor. Inside a conductor again you see electric field is 0 and net charge is 0. Now I come towards how much time it will take in attaining the electrostatic equilibrium. For a good conductor, the attainment of equilibrium is extremely very rapid for good conductor. Achievement of electrostatic equilibrium is very rapid. While is already I told you that it depends upon the nature of a conductor. That is, poor conductor, the conductor, the slower is the approach of electrostatic equilibrium. In fact, if it is of low conductivity, it will take years or even longer time to attain electrostatic equilibrium. So dear student, now you see that approaches towards electrostatic equilibrium is, it depends upon the conductivity of a conductor. For a very good conductor, the equilibrium within the conductor is achieved very rapidly. That is, if it is poor in conductivity, then the process will be slow, and thus there will be a slow approach of electrostatic equilibrium. In fact, if it is of low conductivity, it will take years or even longer time to attain electrostatic equilibrium. Here you see it is taking 10⁻⁻16 seconds to achieve electrostatic equilibrium, but here you see it is taking years, even longer time to achieve electrostatic equilibrium. So this means that it depends upon the conductivity level. They depend upon the conductivity level. Consider the homogeneous. For this purpose we are taking, consider the homogeneous isotropic medium having conductivity sigma and permittivity psi. Which has the volume density consider a homogeneous isotropic media having the same property in all direction, means which has a conductivity sigma and a permittivity psi and a volume density rho naught xyz. If this conducting system is isolated, conducting system is isolated from electric field, it will tend towards equilibrium where there is no excess charge in the interior of a system. When there is no excess charge in the interior of a system. Dear student, you see that again we have taken the homogeneous, isotropic, same property in all direction. Isotropic means same properties in all direction. Having conductivity sigma and permittivity epsilon, which has the volume density rho naught xyz. If this conducting system is isolated from electric field, for example, if there is no external field, or if then it will tend towards equilibrium when there